Cement, a presentation by Jisam Ahmed. I'm a civil engineering student of Alia University and I give a presentation on the cement. Contents. We are discussing some basic concept of cement where we includes introduction, manufacturing of cements, constituents of cement and their role, clinker composition, hydration of cement, test on cement, types of cement and its uses. Introduction. The name Joseph Aspidin is a scientist in UK in the year of 1824 and he invented Portland cement. He used a mixture of limestone, clay and water to make this Portland cement, and this mixture of lime, clay and water was heated at high temperature, and on 21st October of 1824 he was granted a patent for the Portland cement. And before the Portland cement, or before the cement, Portland stone was used in construction. As you can see, St. Paul Cathedral Church, London is full made of Portland stone. Types of materials. In cement, there are mainly clays, claricious, argillaceous and siliceous materials. In calcareous material, limestone, chalk, cement rock, they are mainly used. Scale, clay, cement rock, chalk and mud. And in siliceous material, there's silica and sandstone. Manufacturing of cement. The cement is manufactured by this way, where at first raw material are extracted from the earth crust and it stores in a building or in some places, and then in which proportion we have to mix the amount to make the best cement, we decide that the correction of proportions, and then we fill it in a ball mill and to form powdery. After that heating, we heat those powdery form in a clean, and after the formation of clinker, we take it to another room for its cooling, and then we add some gypsum and store and pack it for the sale. Manufacturing of cement in dry process, and there are also manufacturing of cement for wet process. In wet process we add water and in dry process we don't add water, but those are basically same. As you can see, this is the wet process and this is the dry process. Constituents of cements and their role. The constituents are lime, silica, alumina, iron oxide, magnesia, soda and potash, sulfur trioxide also. The functions of lime are to control the strength and soundness. If lime decreases, strength and setting time decreases. The average proportion of the lime is 63% around in the cement. The silica is around 20% of all of the proportion, and it gives strength. If it increases slow setting time. Alumina responsible for quick setting and it lowers the strength. It is around 6% and mainly 3 to 8%. Iron oxide gives color and helps in fusion of different ingredients, around 3%. Magnesia impacts color and hardness. If it is excess, causes cracks in mortars and concretes in leads to unsoundness. Soda and potash residues causes efflorescence and cracking, around 1%. And sulfur trioxide make the cement unsound. It is approximately 1.5%. And we also use fly ash and gypsum. Fly ash we used to improve the workability of the cement, but it does not affect the strength of the cement, and we use gypsum to adapt to order to increase the setting time. Clinker composition. After the cement burns in the clinker is come, and in the clinker we find four mainly components, that is tricalcium silicate, dicalcium silicate, tricalcium aluminate, tetracalcium aluminoferrate. This is the name, and now we'll discuss details in those things. Calcium silicate. We denote it as C3S, and average proportion is 40%. It provides best cementing property and form the cement is well burnt. It provides early strength and responsible for 7 days strength. It enables clinker easy to grind, increase resistance to freezing and hoeing. Strength high, heat of hydration increases solubility with water. Heat of hydration is 500 joule per gram. Dicalcium silicate, which generally denotes as C2S, it is around 32% of the proportion. It hydrates and hydrates slowly and takes long time to add the strength, that is later strength. It enables clinker hard to grind, decrease resistance and freezing and thawing. Generates low heat of hydration and decreases solubility of water of cement in water. Impacts chemical resistance, and the heat of hydration is 260 joule per gram. The next one is tricalcium aluminate, we denote as C3A. The average proportion is 10.5%. It reacts immediately with the water and responsible for flash set, initial set. It is first compound to react with water. It decreases setting time, hence increased shrinkage and cracking. It weakens resistance to sulfate attack, volume change increase and hence cracking. Heat of hydration increases and lowers ultimate strength. Heat of hydration is 865 joule per gram. And the fourth one is, and the last and the fourth one is tetracalcium aluminate ferrite, we denote as C4AF. It is around 9% of the whole percentage. Responsible for fly ash set, but generates less heat. Poorest cleaning cementing value. It increases. If increases, it decreases the strength of the cement, and heat of hydration is 420 joule per gram. Hydration of cement. Chemical reaction of cement with water to produce CSH gel. This reaction is highly exothermic. Only C3S and C2X reacts with the water to produce C3S2H3, calcium silicate hydride, which is mainly responsible for the strength and densifies as cement sets. Along with CS3 gel, CaOH whole twice, calcium hydroxide is also formed by this product. Calcium hydroxide is an undesirable product because it is used for sulfate attack. Hydration of cement depends on ingredients fineness increases, temperature increases. That's it. Heat of hydration. Amount the heat of hydration in one compound. We compare the heat of hydration with the clinker composition. Now you can see the order of heat of hydration, order of rate of hydration, order of strength, and order of setting time. Sulfate attack. Solid sulfate does not affect severally. Water sulfate proves fatal as it reacts with the gel and volume of cement paste increases in concrete or mortar. These end products cause increase in volume by 227%, which causes concrete to expansion, extensive cracking, loss of bond between cement paste and aggregate. Sources of sulfate. It occurs in soil, groundwater, seawater, present in bricks, and etc. Here is the thing that you can see: C3A hydration, CaH, calcium aluminohydride, sulfate attacks, magnesium or calcium sulfoaluminates in higher volume. This is some pictures of sulfate attack. You can see how the sulfates attacks the wall, the bricks, the concrete, and also the cement. Test on cement. Tests are conducted to determine the properties of cement and regulate various stages in manufacturing for quality. Test on cement. We broadly classified the test on cement in two categories, that is field test and another one is lab test. In field test, we focus on color, presence of lumps, strength and density. But on the other hand, in the lab test, it is mainly classified into two categories. One is physical test and another one is chemical test. Now in the physical test category, we test fineness test, setting time test, we determine consistency test, soundness test and specific gravity test. And on the other hand, in chemical test, loss of ignition, loss of chemical composition, we found this type of things. Test on cement, that is field test. Now we discuss about field test on cement. Cement color should be greenish and gray. It rubbed between the two fingers. If it will be rubbed between the two fingers, it should be feel smooth, not rough. If hand is inserted in a bag on cement, it should be feel cool, not warm. If the cement is thrown in a bucket of water, it should shrink and not float on the water. A thin paste of cement should feel sticky between the fingers. It should be free from lumps. And if we made briquettes, that is made of cement and sand in the proportion is 1:6, it should not break easily under the water for 3 days. Now we discuss on the physical test on cement, and the first one is fineness test. We classify fineness test as C test, air permeability apparatus and Wagner turbine meter. And you can see here is some concept and definition and also some charts available for the fineness test. Consistency test. The test is used to find quantity of mixed in water. Normal consistency is that percentage of water required. Viscosity will be such that Picard's Plunger percent penetrates up to a point 5 to 7 millimeter from bottom of the mold. It is helpful in performing other tests. Setting time test. Setting time is classified into two categories: initial setting time and final setting time. And here is some things that you can see about the setting time. Soundness test. It measures unsoundness due to free lime only, and unsoundness of cement should be limited to 10 millimeter, and expansion of cement should not be more than 0.8%. There are some apparatus that we used for to perform setting time test, soundness test and tensile test, etc. Test on cement, chemical test, loss of ignition. 1 gram sample is heated in a muffled furnace and loss in weight is observed, which should not be more than 4% in general. Chemical composition, ratio of alumina iron oxide should not be more than 0.66, which weight of magnesia should not be less than 6%. Lime saturation factor should be between 0.66 to 1.02. Types of cement. We divide there are many categories of cement and we will discuss it one by one. Ordinary Portland cement. The common grades are OPC 33, OPC 43, OPC 53. 3 days strength, 7 days strength. Fineness is 2250 centimeters square per gram. Rapid hardening cement. CS3 is increased, C2S is decreased plus finer grinding. Fineness is 3250 centimeters square per gram. Rapid hardening cement has more fineness than the ordinary Portland cement, and it uses road repairs in cold countries for first removal of shutter. One day strength is 16 Newton per millimeter squared. Extra rapid hardening cement uses road repairs in cold countries for fast removal of shutter. Mixing plus transporting plus placing of concrete should be within 10 minutes. High alumina cement, bauxite plus limestone plus iron oxide plus increased fineness plus high temperature. It is similar to RCH, but C3A is absent. Use road repairs in cold countries for fast removal of shutter. Refractory cement, high chemical resistance. Sulfate resistant cement. It is similar to OPC, but C3A is decreased. Plus finer grinding. Uses lining in sewers, canals, and coastal areas in sea waters. Portland slag cement. Portland cement clinker plus granulated blast furnace slag plus gypsum, high chemical resistance, sulfate resistance, low heat of hydration. Low heat cement. Low cements of C3A and C3S and more contents of C2S. Slow rate of hardening, slow strength development, prevent shrinkage and cracking, decreases. Mass concerting works, high temperature places, Portland pozzolana cement. Number 8. Portland cement, pozzolanic materials, finer grinding, low rate of strength developed, decrease in early strength, low heat of hydration. Mass conquering works, marine works. Water repellent cement, water and colored cement, quick setting time cement. This cement is fine and OPC gypsum is not used, and these are some kinds of cement. Thank you very much for giving me the patience. Thank you.